welcome to the show, everyone. Today, we're diving into a fascinating story coming out of Johannesburg, where grade 12 students are using lasers and nanoparticles to understand ecosystems.
That's right, Sylvia. Ms. Nomusa's physical sciences class is doing some groundbreaking work, drawing parallels between magnetic attraction and the cyclical flow of matter in a fynbos ecosystem.
Fynbos, for our listeners who might not know, is a unique type of shrubland vegetation found in South Africa. So, how exactly are nanoparticles involved?
Well, they're using ferromagnetic nanoparticles as an analogy for nutrients in the soil. They're studying how the atomic structure, particularly the electron configuration, influences the magnetic properties of these particles.
So, the electron configuration is key? How does that relate to the ecosystem?
Ms. Nomusa is drawing a fascinating parallel to Mendelian genetics. Just as specific gene combinations determine an organism's traits, the electron arrangements dictate the magnetic behavior of the nanoparticles.
That's a really clever analogy. And I understand they're also grappling with some serious data analysis?
Absolutely. They're plotting graphs to show the relationship between distance and magnetic force, demonstrating an inverse square law, much like Newton's law of universal gravitation.
So, the further apart the particles, the weaker the magnetic attraction. How does that tie back into the ecosystem?
Exactly. Ms. Nomusa explains that just as the Earth's gravitational pull diminishes with distance, so too does the magnetic attraction. Think of it like the nutrients pull on a plant decreasing as the distance from the root increases.
Wow, that makes perfect sense. And I hear they're even modeling nanoparticle uptake?
Yes, they're using Michaelis-Menten kinetics to model how a hypothetical plant absorbs these nanoparticles under varying concentrations. This helps them understand saturation points, which is akin to an ecosystem's carrying capacity.
So they're using cutting-edge research to develop targeted nutrient delivery systems to improve crop yields by mimicking nature.